All right, so hi everyone. This is going to be a CS111 review for Professor Chyn. So we were provided some of the practice problems that she had given, as well as the following problem types that will be on the exam. So we were told that there are going to be 4 questions, one on function title lines, one on output, one on recursive function implementation, and one complete the C++ program that's going to involve an array. So with that being said, let me actually share my screen and we could get started on that. Before we start, is there any specific topic or question that you'd like to go over? Otherwise, I'll just probably take a couple of options. Yeah, I see a hand.
Yes. I would like to go over arrays and recursive functions.
Okay, yeah, absolutely,
Mhm.
absolutely.
All right.
All right, let me share my screen with the practice problems and we could take a look at those. Okay, so let's see if I could find some arrays and recursion. All right, so something like this, right? This is a problem that's involving an array. We can start with one of these. This is problem 3 from the practice problems. I believe you should have access to that. So I'm just gonna start off with this one then. Right, so let me actually open up a Sketchpad really quick so we could that's from CS320. Right, so we are going to be doing a function called all_odd, and it's testing to see if all of the elements are odd. All right, so first things first, right, we want to make sure that we're starting out with our title line, right? Because with any function, you want to be creating a title line. So we know that the function is going to be called all_odd, right? And before the function, before the name of the function, we want to say the return type. So what is it returning? It's returning a result of all odd, otherwise not all odd. These are examples of strings because they are a series of characters, right? Anything could be a string like hello, all odd, not all odd, any of that. So we know our return type is going to be a string. So I'm going to say string all odd. Now inside is what my parameters are going to be. And we are going to be putting in a single array because we're testing if all the elements of a two-dimensional array are odd. So for this, I'm going to input a two-dimension array that is composed of integers. So I can say int array, any name I can call it, doesn't really matter, right? And I want to do 2 sets of brackets, right? Because it's going to be a 2D array. One thing that was given to us was the array should have 2 columns and contain integers. So the second of these boxes refers to the columns, right? The first is the rows, the second is the columns. So in here, I want to say 2 to represent 2 columns. So this is going to be my title line. Okay. So we have over here our title line, and we know that also we're going to be returning we're going to be returning a string at the end of this. Okay, so now we need to actually do the test to see if this is truly all odd or not. So anytime that we're going through a 2D array, we're always going to be doing a nested for loop. So I'm going to start out for I, you can just say any index variable is totally fine. We start out with 0, and we're going to say I is less than, what is the, we would need to so we see over here that uh, in the actual function itself, when we have all odd, we're given 3 parameters. So we're given 2 and 2. This is representing our rows and our columns. So in here, I'm going to also have a parameter for my rows and a parameter for my columns. So that's why I'm going to have int r and int c. And the whole thing is because over here, I need to have a condition to stop at. I have to go until I meet all of the rows. And the only way I can do that is if I actually am able to know how many rows and how many columns. And that's getting passed through by the actual question. So this part here, this main function was given to us. So that's how we know this part here. So this allows us to say I is less than R, and R is going to be increased. I'm sorry, I is going to be increased each time. So this is going to allow us to go through all of our rows. Now we also have to do the same thing for the columns. So for now, I can call this J is equal to 0. J is less than this time. C is representing our columns. C, sorry, R, sorry, I, J. Oh my goodness, I'm messing up all the variables. J plus plus. Okay. Right? And this is within the beginning for loop, right? So these are nested, one within another. Let's make sure we have our curly braces. And with that, right, we have our format. So now all we need to do is just go through each of these positions and see if it's odd or not. And we can do this by testing with an if statement. If our array, which is named ARR, at position, well, 2D arrays are very similar to a coordinate plane. We have a row and we have a column. So if array at position ij is odd, how do we test if something is odd? Well, I can just use the modulus. I can say this modded by 2. And the modulus is what gets me the remainder if something is divided by something else. If this is equal to 0, this means that it goes in evenly. It's an even number. If this is equal to 1, on the other hand, that means it doesn't go in evenly, so it's an odd number. Well, this is what we want, right? This is actually what we want it to be because we want to see if it's odd. If it is odd, right, then we know that this number had passed the test. But if any of them are even, we know that we'd immediately cut through the loop and we're done. So if we see something is even, we want to stop the loop. So instead of testing if this is odd, right? Um, because we know that if it's odd, we have to keep testing each of the parts of the loop. I'm going to test if it's even instead, because if it is even, I'm going to immediately return not all odd. So this is going to allow me to say I can break out of the loop early. Because why am I going to continue with the loop if I know that somewhere in here it's going to be even? This also means that if I were to make it to the end of the loop without any problems, so if I'm able to loop through everything and there is not a single uh, even element outside of the loop, I can return all odd. So that's how we're going to do this problem here, right? We just want to see, do a nested for loop, and test at each position array ij. If I mod it by 2, if it's equal to 0, I know something is even here. I immediately stop the loop. I return not all odd. Otherwise, nothing happens, right? This if statement is only going to happen if I actually make it through, if I actually make it to an even number. If all the numbers are odd, it's just never going to do this. It's going to go through the whole loop, and at the very end, return all odd. So with that being said, right, we have our code for this right over here. Okay. Do we have any questions? Yep. Hand raised.
Yeah. Okay. So in this case, so we wouldn't really have to use an else statement to check for the other condition. We can just simply
Yes,
just have return out, turn all out, and that'll be it.
exactly. So
Okay. Mhm.
if I were to have an else statement saying, "Oh, else," um, I could use what's called I just all I want to do is just continue checking elements, right?
Mhm.
It's like, okay, you're good, you're good, you're good. Oh, you're even, you're not good. Immediately I quit. So we
Yeah.
just constantly let it pass. Now, technically, if I were to have an else statement, I could do what's called a continue.
Mhm.
Um, but this is something that you don't really need, honestly, and it will probably make things a little bit more confusing. So you could just
Okay.
kind of think like you're just passing people along.
Mhm.
Okay, so this is our code for this problem right
Oh
here.
yes, one more question.
Sure.
So I know that we don't specify how many rows when we're using it as a parameter, but why is it mandatory that we specify the amount of columns?
It's given to us right here. The array should have 2 columns.
Okay.
Okay, so let's see if there's any other questions that... Oh, look at this, recursive function. All right, this is a good one to do. Um, okay, actually, this one is one of those fill in the blanks. Okay. Okay, so for a question like this, right? For this, we have the recursive function rotate digits moves the first digit to the end of a positive integer. Hang on a second, there's something in the chat. Can we review title lines after? Absolutely, yes, we can definitely review title lines after this. Okay, so we have the recursive function rotate digits, and it moves the first digit to the end
Okay.
of a positive integer. All other digits move one place to the left.
Yep.
For example, rotate digits 1, 2, 3, 4, 5 returns 2, 3, 4, 5, 1. So the
Yep.
1 goes at the
Goes
end.
behind everything. Yep.
Yeah,
Goes behind
exactly.
everything.
Okay. So we have over here, some pieces of the code have been replaced by these little placeholders. To answer the 5 parts of this question, we're going to just kind of fill in the blank. Okay. So we're going to start out over here. We're given int rotate digits int x. So x is our parameter. X is, you could think of this 1, 2, 3, 4, 5. So we have over here part A. if x is less than 10, what would we insert here? Well, we want to say the base case of our recursion. So what exactly is going on with recursion is that we have two cases, a base case and a recursive case. The recursive case is going to be over here, what we're going to be returning. So let's think about what we're doing each time we have this over here. All right, so we're moving this digit to the end of a positive integer. Okay, so we're going to have to loop through every one of these guys, right? We're going to save this digit, right? Put it into its own little variable. I'll call that, let's say, z. Actually, in this case, I think they used y, so I'll use y. Okay, and we're going to loop through all of these guys. So the way I like to think of it is we're going to kind of chop digits off. Is this the last digit? Nope, chop it off. Is this the last digit? Nope, chop it off. If this is the last digit, nope, chop it off. This is the last digit, okay? Now at this point, right, we're gonna insert y at the end over here. So for that matter, right, we're gonna keep going until we reach the very end, and then we're going to just simply return our new number. So at the end of this, right, when x is less than 10, meaning it's a one-digit number, over here, we're simply just going to return our x. So we're just going to return our number. So this is going to get us out of our function at the very end of this. Okay? Now, otherwise, right, if this is not the case, we're going to move on to the next part. And this is just going to be saying int y is equal to something. Well, what we want to do is before we do anything else, right, we want to get this last digit here. And we do this by saving it by doing our modulus function, right? We know that we can do this by saying x mod 10, right? So actually, for that matter, we're supposed to kind of go the other way around, right? So with questions like this, it's best to start at the end and work your way to the left. And the reason for this is because x mod 10 chops the digit off from here. Let's think about what's going on here. X is 1, 2, 3, 4, 5, modded by 10. If we were to divide this by 10, our remainder is going to be 5, which is this last digit here. So what we're going to do is we're going to chop all these digits off. So chop, 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 chop until we get to this last one. Then we're going to save this last one and put it at the end. So what we want to do is we want to say, what is our last digit? Well, our last digit is x mod 10. So in a case like this, right, part B, we're just going to say x mod 10. And that's just going to save y as our last digit. Next, we have x is equal to part C. Okay, so we have here, now what we want to do is we have this last digit. Now we want to chop off the digit, right? We want to essentially dig away at this number until we're down to this part here. Okay, well, to do that, now instead of doing x mod 10, I can say x divided by 10. So x mod 10 extracts the last digit. X divided by 10 will chop it off. So we're going to constantly go through this pattern of extracting and then chopping. So what we're going to do is we're going to say x is equal to, we're going to say, call this function again, but with this digit chopped off. We've taken our 5, we're done with it, we don't need it again. So I'm going to call the function again. Let's just say rd, rotate digits. And this time, instead of saying x, I'm going to just change it a little by doing x divided by 10. Okay, and then this is just set equal to x, right? So we're constantly going to chop, 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 extract and chop, extract and chop. And each time that this runs, that's going to happen. Now we move on to the next line here. Int z now is going to be equal to part d. Okay, so now that we've chopped off this digit, right, we want to store the next one over here. And how do we do that? Well, simply, again, just x mod 10. So over here again, we're just going to have x mod 10. And then finally, right, we want to, for part E, we want to be able to find a way to put all of our stuff back together again, right? So we know that Z is going to be holding the last digit, right? Or well, the first one in this case. So each time we're going to go chop, 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 chop until we get to this one, right? That's what our base case is telling us. And then this guy over here ends up being our Z. So now we want to go backwards and work our way backwards. And the way that we get to do this is now we're going to be putting things back together. So we're going to start out with our digit actually, hold on a second. So to put things back together again, what we want to do is we want to use this kind of formula to put things back together. If I take a number, let's say 1, right? Or in this case, well, now it's going to be 2, right? Because 2 is going to be the first new digit. I want to, actually, technically, right? Where did we stop at? We stopped at 1. Let's trace where this is going. 1 divided by 10, because we're dealing with integers, is just going to end up being 0. So now 0, well, now I want to bring back my 2. So how do I do that? Well, if I multiply this by 100, right, this is going to get me back to, well, this is 0, so this is going to end up being 0. But what I can do is I can add back a 10, right? So now I'm left with 10. And I can now multiply this 10 by the digit that I want to put back, 2. So 10 times 2 is equal to 20, right? And I can add back 20 plus, what is z? Well, z is going to be my 1 that I want to put back here, 21. So now we have the 2 and we have the 1 after the 2. So we've essentially swapped these two places. Let's loop back through this with our new number, right? Now this is going to be, instead of 0, 21. So 21 times 100 is going to leave me off with 2100. Okay? I'm going to add 10 to this. This is going to give me 2110, right? actually, I'm sorry. This is supposed to be 10 times y, right? So 10 times what is my y? Well, that's going to be my next one here. So instead of 10, this is going to be 30. So now I'm going to have 2, 1, 3, 0, right? This is the 3, the next one. And then plus the z, right? Actually, I'm sorry. This should have been x divided by 10. So this actually should have been a 0, right? So we're getting rid of that extra one. So now we have 2,000. Actually, sorry, that should be 200, not 2,000, right? Because we just chopped off the 1, right? We had 21, we chopped off the 1, we had 2. Multiply by 100, that gets you 200. Plus, what is 10 times y? Well, 10 times the next value we want to add is 3. So 10 times 3 is 30. So now we're going to be left with 230, right? Now I want to add back in my z. What is my z? The same thing I want to put back. 1. We're left with 2, 3, 1. See? Now we're kind of getting there, right? We want to eventually get 2, 3, 4, 5, 1. We have 2, 3, 1. So every time we do this, we're essentially making a little placeholder, right, for our number and adding it back. So we're going to be left with 2, 3, 4, then 4, 1, then 2, 3, 4, 5, 1, right? If we continue this up. So the main formula that you want to keep in mind, I don't think there would be a problem this tricky on the exam, but the main thing you want to keep in mind is I can take things apart. I could extract digits by doing x mod 10, and I can chop digits off by doing x divided by 10, right? Now, if I want to put things back together, right, I want to take a number, I want to times it by 10, and I want to add back a digit. Let's just say y for this case, right? So if I have a number 2, I multiply by 10, that gets me 20, plus my y, right? This is the formula that is going to be key for most of these recursion-based questions, right? The reason that we're multiplying by 100 in this case is because we want to put back 2 digits at the same time. We want to put back the next digit and our first digit. So this is a way to keep track of that, to constantly put back in a 2, 1, then a 3, 1, then a 4, 1, then a 5, 1. So we're putting those 2 digits together. That's why we're grouping them together and having them as this times by 100. So this one's a tricky question, but it ultimately breaks down into this case over here. You take your x, or in this case, x divided by 10, because we're chopping off the 1 each time. Taking a number times it by 10 gets you the number with a 0. Now I can add back a digit easily. So this is how we do these recursion-based questions for a question like this. And again, I don't think there would be a question this difficult on the exam, unless it's like a fill in the blank like this. But you're not going to be really expected to code out this whole thing. But maybe you'll be expected to code out something smaller like this. So let's say if we could do one more recursion question and then we'll move on to title lines. Okay, actually, this is a good one too. This is the same question, but slightly different, right? So what we should do in this case, let's actually, I'll do this one quickly just because the last one is going to be a little different. And then I want to try to do one that would be one that you'd probably see more of on the actual exam itself, right? So if x is less than 10, right? Just like before, this is the same as our previous base case. All we're going to do is just return our x, right? So in this case, right, this should actually be return x. Oh, I'm sorry. Yeah, so I forgot about part A. Part A, what are we doing here? We're taking in an integer, so this is just going to be int x up here. Right? Down here, part B, this is just going to be return x. Now, part C, what are we taking in? Well, each time we're going to be taking in the last digit, right? So how do we do that? Well, we just do x mod 10, right? Same thing. You see the same patterns going on here. Then Z, right? Z in this case now, we're going to essentially replacements has said Z to the next to last digit in X, right? So now we're going to be saving the next to last. So we want to chop off the digit, X divided by 10, and then extract the next digit from that, right? So same as last time. Oops. Wait, X mod, X divided by 10, mod 10. Yeah, okay. Right? Then we do um our function call, right? So same as last time, we chop off x divided by 100, right? So chop off two digits, leave a space, and add back our original value. So if we have 1, 2, 3, 4, 5, right? We saved both of these digits, this one and this one. All right, we're going to divide by 100, so we're going to be left with 1, 2, 3. You're going to leave a space by multiplying by 10 and add back our y. What's our y? 4, right? So this is constantly going to run this loop until you get to the very end, right? And then what we want to do is we want to bring back our 5 essentially. So once we keep chopping this off, chopping this off, chopping this off, right? Now we want to essentially be left with the last number coming back. So what this is going to let me do is now I'm going to take my x, right? I'm going to leave a space for it by multiplying by 10. So if this was, there was like a 1 here, right? Actually, technically, we'd be starting at 0, right? And then we add back in our z, right? First things first, before we do anything, we want to add back in our z. What was our z? We saved it as 5. So 0 plus 5, this is just going to get me 5 at the very beginning, right? Now, every other time this runs, I'm going to leave a space, and then I'm going to add back in the next number, 1. Multiply by 10, put another number, 2, 3, and then 4. So that's how we're kind of doing these kinds of problems. So the recursion is honestly the toughest part, but like the more that you do with them, um, like the more it kind of you can see the pattern that's kind of going on with it. Okay, let's do a couple of title line questions. Right. Write the best title lines for the functions that are called by the following main program. Do not supply the blocks. So the importance about title lines is that when we have functions, right, we want to define what their return type is and what their parameters are. So when we do this, right, it's going to look similar to this. Your return type, your function name, and then inside, it's going to be your parameters, or your arguments, whatever you'd like to call it. So in a case like this, right, we're always going to just be following these three components. So let's start off with title line A. Okay, we have over here CH is equal to function A, ch, comma, ch. Okay, what is ch, right? What are we setting this equal to? Well, ch is a character. So we're going to have a character as our data type. Then we're going to have our function name A. And then what are our two parameters? ch. Both of these are going to be characters. So this is going to be character A and character B. You can call them whatever you want. You can call them X and Y, A and B, whatever you'd like for them. So it doesn't really matter too much what you call them. Um, so in the case of this one here, right, they said X and Y. So that's fine. All right, so now we have the second one, which is going to be B, right? So this time, what is B set equal to? B is R1 at position 0. What is R1? R1 is an array of doubles. Okay, so that means that we're going to be returning, right? R1 at position 0, a double. So this time I'm going to be starting out with a double as my return type. Then my function name is B. And what are my parameters? What am I plugging in? num0 and ch. num0 is coming from this integer array. So this is an integer. You can just call that A or B or X or Y, whatever. Int A, and then the second one is just a character. So I can call this char B. Okay, right, so that's exactly what we got over here. Okay, I'm just gonna erase to leave a little bit more room. Okay, now C. C is going to be, yeah, there's a question?
Yeah, so when you're defining a 1D array in in your function, you don't need to put the brackets.
So it depends on what you're looking for. When we do a later
Okay.
question, there's probably going to be an actual array that gets plugged in, but notice this is num at position 2.
Mm-hmm.
Num at position 2 is an entry within the array. So that's
Yeah.
just going to be an integer.
Okay.
If it was saying num without the brackets, this is referring to the entire array. So you would
Okay.
need to include the brackets.
Okay.
Yeah, good question. All right, now C, right? C is set equal to num2. So again, that's just going to be an int. Name of our function is C. Now this is a little different. This is actually plugging in a function. This is plugging in function A. So this is going to end up being one parameter only because what's getting plugged in? Function A plugged in with ch. Okay. What is A returning? A is going to be returning a character, meaning that this whole thing, once the function is solved, is only going to be a character. Okay,
Okay,
again,
so if it's a function within a function, right? So you just focus on what it returns.
you got it. Yep.
Okay. All right.
So now over here, we're going to do D, all right? And D, same thing. Yeah, there's a question?
And whatever returns would be the most outer loop. That'll be the most outer bracket uh variable, right?
Yes, exactly.
Yeah.
So in a case like this, for D, now we got two functions going on here, right? D and plugged into D is another version of D. So now, right, we need to kind of find what is D plugging in to find what its return type is. So for this, we're going to work inside out instead of outside in. Let's look at this one here. I'm not sure D's return type just yet, but soon we'll find out. So I'll start out with D. What's inside of D? CH, comma, num1. CH is a character, so we could just say char x. And num1 is an integer, because it comes from that integer array. Int y. Okay. So we don't know what this returns, but notice D acts as the return type of D acts as the first parameter of the outer calling of D. We know that D has to have the same title line, the same parameters for every single time that it's called. So because of that, the first parameter must always be a character. D's output is the first parameter here, meaning that D must also output a character for this to work out. Because D's output is being used as the first parameter in the outer call. And in the inner call, we know the inner call's parameter must be a character. So we kind of have to use a little bit of a detective skill here to find out specifically what its data type is based on every single instance of it. Question?
Yeah, so it's always the first parameter that's going to be the output.
For D,
That's
yes.
first. Okay.
Because take a
So
look
yeah,
at what's going on here. Over here, the outer call is calling a function D and
yeah.
5. The inner call of D is calling a character and an integer.
hmm
Therefore, we know that every single time I call D, I need a character and an integer.
Yeah.
Because D is also the output of this, right? This whole thing needs to resolve itself to a
Yes.
character. Therefore, I know the output of D also has to be a character.
Oh, okay. I get it.
Another question? No?
Yeah. So basically, well, when it's assigned, the parameter is going to be uh, the most outer characteristic variable, and when it's not assigned, it's always going to be the the inside parameters of first variable.
It kind of depends on what the question is because I could have had D as the second parameter, right? This 5 and the D could have been switched, right? The order could have been switched. The key is it has to be consistent. This is telling me that the first parameter of D inside has to be a character, and the second has to be an integer. The outer call is saying, okay, some unknown D, which we don't know its output yet, and an integer. Well, based on the inside, this has to be a character. Therefore, this call of D, its output, also has to be a character.
Mm. Okay. And if they were switched, then it will be an input. It will be a integer because the five will be first. Correct?
Yeah, yeah.
Okay.
So if the num1 was switched, right, and their position was also switched, right, then we know that it would have to be an integer instead. So it's just kind of based on like kind of the context clues that are going on. Okay, and then lastly we have E. So E has a lot going on too, but let's just take it one step at a time. All right, E is inside of function A. So where is E? E is over here. This whole thing is E. Notice that A is involved in here too. But let's start out with what E is first. Okay, we don't know its return type just yet, but we do know what's inside of it. Num0, that's an integer. Okay, plus, oh, actually, I'm sorry. Num0 plus R1 at position 1. So this is actually an int plus a double. Now, anytime that there's an integer plus a double, even though they're different data types, it automatically gets converted to the double type because all integers are doubles, but not all doubles are integers. Think about it. 2 can be written as 2.0, but 2.1 cannot be written as an integer. So because of this, an integer plus a double is just going to get me a double. So I can call this double x as my first parameter, right? That's that num0 plus r11. And my second parameter is r1. Now, notice there are no brackets around r1. That means it's referring to the array as a whole. This time, we need to refer to it as an array. So now this whole thing, right, is going to be passed in as double with brackets. Okay, so this is going to be double bracket, and I could just say y. So if this had brackets on it here, it would just be a double. But because it doesn't, it's referring to the array as a whole. So this whole data type has to be an array. Okay. So next, yeah, question?
So yeah, I noticed that you put double, then the brackets, and then you put y afterwards. Is that how it's supposed to be organized when you're putting it as a parameter?
Actually, it's supposed to be reversed.
Okay, okay.
Yeah, so it should
Mhm.
be double y and then the array brackets.
Mhm.
So it's the name first and then the brackets.
Yeah.
Okay. And this actually this does make sense because we call the name first and then we call the brackets after. Right. Now at this point, right? Yeah, question?
This is just a what if question, but what if num0 was a string and then r1 was an integer, that was a double value? Would that, I know that would lead to a technical error, but how would we go around that situationally wise?
I'm sorry, if which one was what was the situation again?
What if for E, right, for the title line for E,
Hmm.
what if num0 was an integer and then r1 was a string value or a character value?
Yeah, so that would definitely cause an error.
Okay.
Yeah. But if let's say they were both strings, right? You know, you could put two strings together, or if it's a character in a string, right? A character in a string can become a string. Yeah, you just can't do like a string and an integer unless you were to like parse it or something, but I don't think you guys have done parsing yet, so don't even worry about that. That's kind of like just changing one data type into another.
Other, yeah.
Yeah, so that's not really something, it's always going to be compatible unless the question's like asking like, hey, would there be an error if you do this? And then like, there is an error. Okay, now the last thing we need to do is we need to get the data type of E, right? Because we never did its return type. So what's going on here, right, is E, its return type is getting plugged in to A. And what was A again? A plugs in two characters, right? We know that A is plugging in the return of E and another character, meaning the return of E must also be a character. So this is going to end up being character E. So that's the end of that question. Any other questions about the title line in general? Yep, question.
Okay, so how do you determine the return type of the function e?
So you see E is being plugged in as a parameter of A,
Mm-hmm.
right? So it has to be consistent with A's title line. And what is A's title line? 2 characters.
So how would you determine it if you didn't already know the title line of A?
Sometimes you have to work backwards.
Okay.
So maybe you have to go to a different part of the problem first and then solve for A's title line and then work backwards. But there's always going to
Okay.
be enough clues to find out.
Hmm.
The key here is you want every single thing to be consistent.
Okay.
Okay, we could do another title line question if you guys would like.
Yeah, that would be fine.
Okay, cool. All right, so we could do this one over here. Yeah, this one also has kind of, I think this one's kind of similar to the other one. $22. Okay, let's do 21 and 22 then. All right, so we're starting out over here with F1. Okay, so F1, all right, F1 over here, we know that it's being set equal to DD1. Okay, so I know I'm going to have F1 and DD1, right? DD is an integer array, meaning DD at position 1 is just simply an integer. So this is just going to be integer F1, right? And we know it's being set equal to this, so the data types have to match. What's inside? All right, we have DD2 plus DD1. So those are 2 integers. So simply this is just going to be an integer. And then comma, DD2 is yet another integer. Okay, so that's going to be for function 1. Okay, function 2 now. It's being set equal to st0. St is a string array. So st0 is just simply a string. So this is just going to be string f2 and then the inside is going to be dd0 plus dd1. So just like last time, right? This is going to be an int, right? Then we have dd0 and another dd0, right? So this is going to be another int. And then string 2, which is just going to be another string. Okay, so over here, again, you can name them anything you want. It does not matter. This is just X, Y, Z, W. The most important thing is you have an int, an int, an int, and a string in a case like this. Okay, we have F3. F3 is being set equal to DD1. So I know F3 is simply going to be DD, which is an int. So int F3, and then inside is going to be ST. But remember, there's no brackets. This is referring to ST as a whole. So ST is going to be a string X with brackets. And same thing here, another ST. So this is going to be it's going to be a string. We can call this Y. with brackets. And then the last one is 3. 3 is just an integer, right? That's totally fine to say on its own. I could just say that's int z. Right? And then just as we have here, right? String w bracket, string x bracket, int c. Again, the names don't matter. The key is just the data types. Okay. F4 now. F4, now notice, F4 is not returning anything. So there's two cases in a case like this. Either it just won't return anything and it's a void function, or it might return something later on in the function. So let's just be on the safe side and let's kind of leave that blank for the time being. So st1 is on the inside. We know that's just simply going to be a string. And 1 is an int. Okay. Now, again, I see over here there is another instance of F4. If this F4 was not in there at all, I would say immediately this would be a void function. But because there is another F4, we have to see for sure if this is going to be the case or not. So this is like one of those where it's like, you might not see the return type or one of the parameters right now, but you might see it later. Let's move on to this line over here and take a look. Okay, there's a lot going on over here. First things first, F4 is being called again. This whole thing is F4. This piece is F5. Now, first things first, F4 seems to have being set equal to a Boolean. That means this is not going to be a void type. This is going to end up being a Boolean. So sometimes you have to look at other places in the question to tell you what it's equal to. Next, we also see that it has two parameters, F5 and DD1. Well, we know DD1 is an int, right? And that is consistent with what we have here. But we also don't know what F5's parameter is. Given that F5 is in the first position, and we said the first position of F4 has to be a string, I know that F5 is going to have to return a string. What else is inside F5? DD1, that's an integer. ST, notice, no brackets. This is referring to the string array as a whole. This is going to be string, could say y, and then brackets. Okay, and we can see over here the answers for both of those. So that's kind of the process that you want to be going through as you're doing these questions. Okay, feeling good about the title lines?
Yes, I'm starting to understand those 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 ones where like the function within a function, yeah. And those are the
Yeah,
ones I struggle the most with other ones, yeah.
they're meant to be tricky. The best way to
Yeah.
do it is just constantly do them over and over again.
Yeah, because like now I'm realizing like I just need to focus simply what's inside the function when it's like if it's like a function within a function, just focus on what's inside of it and then
Yeah,
work from there.
absolutely.
Yeah.
Yeah, absolutely. All right, let's do 22. So 22, this is simply just an output question, right? So we're going to just be tasked to finding what is the output of all of these lines of code. So line A over here, we have our main function. we have a string array and two normal string variables. So string X is an array of strings, and then we have an array, a variable Y and a variable Z. Cool. All right, C out X at position 111 mod 3. Okay, so we kind of have a lot going on over here. So let's take it step by step. Work from the inside out. We have to solve what is 111 mod 3. So we could just do this by just doing simple division. 3 goes into 11 3 times. Minus this gets you 2. Bring down the 1. 3 goes into 21 7 times. 37. Okay, so 37, right? We know that this goes in evenly. Our remainder is 0. So when we do 111 mod 3, this is simply 0. X at position 0, that's just Z. So that's just going to output Z. The quotes are important here, right? Because we're dealing with string. Okay. So next we have, we're doing a function, right? In the next line, calling function A and plugging in X and X at position 3. So in a case like this, we want to make sure that we're using the, functions that are given up here, right? We have the void function. And we're plugging in string X array, right? This is going to just be simply X, which is an array. And what is string Y? String Y is X at position 3. What is that? Position 1, position 2, 0, 1, 2, 3. That's just W. X, now going inside, X at position 0 gets set to Y. Okay, so that means X at position 0 gets set to W. So Z now becomes W. Y is now set to X at position 1. What is X at position 1? Y. Our function ends. But something to keep in mind with these functions. Was our value saved? It's only saved if it's an array or passed by reference. That means unless I have brackets or an ampersand, the value's not saved. Well, the first one was saved because it's an array. This was saved. The second one was not saved because it was just a string variable, right? So this would be not saved in that case, right? We don't have the ampersand. So W, right? Or in this case, our Y, which is W, right? This would not get changed, right? So now we're going to output in the next line x0 and x3. Well, x0 was just changed to W. x3, on the other hand, was not changed because W was a string originally. It was not given an ampersand. Therefore, it was not saved. If it was given an ampersand, then it would have been saved and it would have been equal to Y. But it was not. So we're going to just have a W and another W. So this is just going to be W, W. Right, and both of these guys have quotes around them. Okay. So that's a key difference here, right? When you're doing a function, know when your values are saved. They're only saved if it's passed by reference, meaning it has to be an array or there has to be an ampersand before the variable. Otherwise, your values are only local within the function. So if you call a cout after the function, only if those values were saved would they be updated. Okay, so that's B. Now we call function B before we get to line C. B is going to call X, which is our array here, and it's going to call Z. What is Z? Well, Z is this string over here, which is equal to 111. Notice what's different here. We have an ampersand. Any changes to this Y, which is just the string 111, get actually saved. That's what this question is testing, if you know how to do that or not. So now let's take a look. X at position 0 is equal to Y. Okay? X at position 0, it used to be Z, it was W, now it's set to 111 because that's what Y is equal to. Y is now going to be set to X at position 2. That means 111 is now equal to, what is X at position 2? X, but the letter X, not the actual variable X. So now when we're asked to output in the next line, X at position 0 and then Z, okay, X at position 0, we changed that to 111. Z, on the other hand, was the variable that was passed into this, right? It was 111. And because now we changed that permanently to X because it had an ampersand. The previous one did not, so we used the old value, which was the W. This changed, so now this is going to be X. Okay, so A, B, C's done. Now D. Plug in C, function C. We're going to plug in X, and then we're going to do 5. So X is still the same array that we're dealing with. Y is just going to be 5. All right. If Y is less than 2, 5 is not less than 2, so we don't return. Otherwise, cout X at position Y. Okay, cout X at position 5. 0, 1, 2, 3, 4, 5. We're going to cout U. Then we're going to go back into our function, plug back in X, but this time Y divided by 2. 5 is an integer, so when we do division on this, it gets floored at 2. All right, technically it's 2.5, but we can't hold a decimal, so it's just becoming 2. Okay, do it all over again. If Y, now this is 2, is less than 2, 2 is not less than 2, we don't return. Go to the else. Cout X at position Y. X at position 2 is equal to X. Right? I see that right here. Okay. Now go to the next part. C is equal to X, Y divided by 2. All right. Now we say 2 divided by 2 is equal to 1. Y is now 1. If Y is less than 2, 1 is less than 2, we return. So we just return out of that. So at that point, we end that, and we know that D is going to just be UX. Now notice, Y did not have an ampersand around it. So these values don't get saved. Y, which was just 5 at the end, right? Well, 5, you're not going to just change the value of 5. It's not being held in a variable. I can't just say, yeah, the number 5 is now equal to 10 or something. So that was never going to change in the first place. So those values of int y stay local within that function. Once we leave, they're gone. Okay, and lastly, E. We have a for loop. For int I equals 0, I is less than 2, I plus plus, go back in to C, X, and I. Okay, so we're going back in here, and this time our X is going to be equal to, okay, for int I is equal to 0, so this starts out at 0. Okay, we're doing the function again. If y is equal less than 2, y is 0. 0 is less than 2. Return out. We're just not going to print anything out. Now we increment by 1. I is now going to be equal to 1. Right? It's still valid. 1 is less than 2, so we're good. All right, so now this time we plug back into the function, and we have x and 1. If y, which is 1, is less than 2, that's true, return out. Okay, we return out. We're done with that. Now, right, we're going to increment. This becomes 2 now. Is 2 less than 2? No, that's not true. Therefore, we stop this loop. So nothing got printed for E. So E is just nothing. Otherwise, this is going to be the rest of the stuff that we have, right? We have Z, WW, 111X, UX, and then E is just nothing, right? That's what we have over here. Questions about that?
Okay, so when working with this, you just simply just follow the functionality of the code and then just like determine what is gonna happen to the line afterwards.
Yeah, exactly.
Okay. Okay.
And just make sure you're keeping track of things, right? Because
Yeah.
if things are arrays or if they're passed by reference with the ampersand, it gets saved permanently.
hmm
And those might be used in later parts of the problem.
Okay, so just make sure just like write certain things down, just like remember certain things.
Yes, exactly.
Okay.
Another question?
Yes, I think I was reading this wrong, but uh in void C, doesn't it go on forever a little bit if uh it says C X and then Y divided by 2?
Well, it's going to stop because if y is less than 2, you return out of the function.
Uh,
So our loop only
uh,
ever plugged in 0 and 1 into this. So we just straight up returned out each time. If it was
uh,
2, on the other hand, if this said I is less than or equal to 2, I would have plugged in 2, and 2 wouldn't have been less than 2. So then I would go do the rest of the function.
right. Okay. And also to keep in mind, with what you said previously, when when the string when a string index is being initialized along with the ampersand reference being permanently added, that's when I should keep in mind about permanent changes.
You got it.
Okay.
Okay. Any other questions?
So the array, right? So that automatically calls by reference.
Yep, you got it.
Okay.
The reason for this is actually because an array is not your normal data type. So you're
Mm,
used to dealing with data types that are called primitives. Those are integers, strings, doubles, just ordinary data types.
mm,
Arrays are classified as objects, which you're going to learn more about
okay.
in 211 and 212.
Okay.
Because of that, any change to an object is permanent.
Hmm. Okay.
Yeah, but for the purposes of this class, just know that if it's an array or an ampersand, it saves. Otherwise, it stays only in the function. Once you leave the function, it's gone forever.
Yeah, so whatever you do inside the function is gonna affect everything. It's gonna affect the data that's in the code.
Yep,
Okay.
exactly. Any other questions? Any other things you want to go over? I mean, at this point, we kind of went through all the different questions. So,
I like to do one more recursive.
okay. Yulong, would you like to take over at this point?
I mean, do you want me to?
Sure
I
if you
don't,
want.
just recursion. Let me see. I gotta find the email for all the practice problems.
I have a quick question,
Could
if you
somebody?
guys.
Yeah, what's your question?
My keyboard is dead right now, so could we do one more recursion problem and one more function problem, if you guys don't mind?
Yeah, absolutely. Let me put the problems in the chat. Okay, so yeah, I think you should be able to see them, Yulong.
Yeah.
Do you guys have any particular question in mind? Or do you want us to just pick a random one, or?
Let's pick a random question.
Okay.
How about question 52?
52.
Yeah, let's try 52.
Or just skip it. Oh, here. So write a function called
Also, since we are towards like over halfway through the session, like if you have to get going for any reason, if you could also just fill out the feedback form, which I'll put in the chat. Just because I know like it is a, long session and everything. So if you have to get going early, or if you just have like some feedback that you want to share, before the session ends, if you could fill that out, that would be appreciated.
uh, so we just want to keep scroll. Okay. So for this one, we would just alternate. Right. Look, we want to alternate between these two. So we do 1, 3, 1, 0, 7, 2. Right. So we would want to first go all the way down to the first digit, which is essentially doing the division like we did before to move our placement down. Yeah.
Okay,
So
so what's our goal for this function? What are we trying
uh
to do?
where we combine these two numbers into one number, but
Oh,
we
okay.
keep changing the order. So for this one, right, we have 117 and then 302. We want to have it as 1, and then 3, 1, 0, and then 7, 2, right?
Hmm. Wait, so 1 and 1 combines together, and then what
No,
about the 7?
it'd be 1,
Oh, oh,
3,
oh, 1 and 3.
and
Okay.
then we'll alternate back to this first one, do
Oh,
the next digit, and we'll do that
okay,
for this one too.
okay.
Uh, so like before, we recursively go down to the very first digit, right? Where we just divide by 10. So with 1, is this too small, by the way?
It's big enough.
117. Okay. And then we have it for both 302 also. Uh, yeah, to recursively call it, we just call this function, just
Okay.
dividing it by 10. So eventually, we want a base case where if it is uh less than 0 or less than or equal to 0, we just return it. So how do I explain this? Let's see. I mean, eventually when we just recursively call this, we'll end up having this first digit here. We would then have to multiply this first digit by, we'll save the first digit as x, the second as y, I guess, right? We would want x to be multiplied by 10, right? Let me think. I'm sorry, I looked here and I got confused. Multiply 100.
I think it's similar to the one we did before in that we leave two placeholders, right? That's kind of like the 100 times the like the function itself. And then like we kind of chop those digits off, right? So like the x
Mm-hmm.
is like the for the first parameter and then the y is for the other. And then
Yep.
you're gonna add those back in at the end, right? So because there's like two digits that you're working with at a time, I think that's why you're doing the 100.
The 100 would be, this would be 100. Then, sorry.
So like if you had, let's say you had like the number like 10 or something, or in this case, like 11, right? Like for the 117, right? You're gonna multiply
Mm-hmm.
by 100, leave two zeros, and then one of the digits goes for like the 3, and then the other digit would go for like the 7, right?
Okay.
Because like you're interleaving them. So if we were dealing with just like one digit at a time, that's when we would have like the times 10 method, right? Because every time that you're multiplying by 10 or like 100, you're leaving a placeholder to add something later on.
Mm-hmm. So, here, 100. Sorry, did you have a question?
Oh yeah, there was a good amount of lag that just happened, so I didn't hear what you said just now.
Oh, from my end or just in general?
Yeah, from your end. Yeah,
My bad. I don't know. I
that's
feel
all
like
right.
my internet's not good.
Okay.
Um,
Okay, so simply you're just okay, so you're taking the values and you're storing them to others, and then at the end you're supposed to rearrange them in a certain way.
right.
Okay.
So, I'm sorry, but I'm just stuck now.
Yeah, honestly, this one's like really tricky.
Yeah.
This interchange.
Yeah, that's why I selected it simply because like I think she
Oh
might do a
wait.
little bit of a curveball, but just to get the harder ones out the way so like, it could be, we're not stumped that much because
10. Eventually this is 1. This is 3. That's 13.
Hmm.
And 113. 10. It should be 1 and 0, right?
Yeah.
So 1300 plus just 10. 1, 0. This is 1310. 10, 7, 2. 72. And you did times 100. Yeah. Well, I mean, explaining this part is uh, hmm.
Hmm.
So if we are to calling this right, we'll eventually hit this 1 and 3. If we do it one more time, this will be 0. So it'll just return 0. So we have 0 here, right? But the
Hmm.
current x is this current 1 and 3. So we'll just multiply that by 10 and then add the 3. And then this 13 will be returned for the previous in interlaced digit, which will be back here again. And so when this is 13, that digit for x and y would be 1 and 0, because oh shit, I should have tracked that number. See, like I don't intuitively
Oh
do
wait, so
this, just not
13 is
explain it.
for the variable x?
Oh no, this is for this when it's returned for the next or like the previous
Oh, okay,
recursive
so that replaces
recursive
that
call.
call.
Yeah.
So okay, replaces that. Okay.
Yeah, because I think you're kind of like, okay, when you're doing recursion, like you're working backwards in a way, like you're writing it all out and then like you're chopping the digits off as you're going along. So like you're kind of going to be like going until like you have no digits, right? And then kind of
Hmm.
working your way backwards and rebuilding the number. That's kind of
Okay.
the gist of like recursion in general.
So on this recursive call, the number should be 11 and 30, right?
Yeah.
I wish I could just draw this better. Let me see
So
if
those are
I
gonna be the values that we're
can
working with.
connect my iPad. Sorry, what?
So those are the values that we're working with.
Yeah.
Oh, okay.
So let me see if I can connect my iPad and I can draw it better. Sorry. Let's see. Oh, I don't have it set up. Shit, never mind. I I can't connect my iPad.
Yeah, don't worry about it.
Uh,
I'm gonna be honest, I really think this is kind of like beyond the scope of the exam a little bit. I mean, it it kind of does encompass like a lot of the different themes that we kind of were going over. Um, but I would kind of focus in more on like ones that might be a little bit more simpler. The main key to get out of this really is the idea of chopping digits off and putting them back together. So if you understand the fact that every time that we call this function, we chop off a digit from x and we chop off a digit from y by doing the x divided by 10 and y divided by 10, and then we add back that plus 10, right? Or actually times the technically the 100, right, is kind of dealing with the two digits at the same time. If it was just the one digit at each time, if we were just dealing with one number, right, we would just say like 10 times that, and then adding back the individual digits, the x mod 10 and the y mod 10. This is a little bit more complicated because you're kind of dealing with the two numbers and everything, but the main thing is you take your recursive call and each time you call it, you chop a digit off. And then when you put it back together again, you multiply by, let's say, 10, and then have that 10 times the digit you're going to add back.
Okay. Yeah, because adding that zero,
Exactly. Like you
so it
add
has like a
that
place
0,
value.
you
Okay.
got it. Yeah.
Mhm.
Yeah, I mean, yeah, for like the number parts, just learn how to chop off the numbers, I guess.
Yeah.
Question?
Yeah, so basically the process is divide by 10, uh, divide by 10 plus 10, and then plus the mod, basically. So divide by 10 plus 10 plus mod, theoretically.
Exactly. Yeah.
Okay.
That's the formula with these questions. They're like all these questions are gonna have
Uh,
some sort of combination of that formula.
Divide by 10 plus 10 plus 10 plus mod. Okay.
is there any other like questions for like 52 or like recursion in general? No. I mean, I
Even
guess
though
we
it's
don't. Sorry,
there's
you can go ahead.
a question, even though it's going backwards, x is the digit that is multiplied by the recursive form. Oh wait, I guess it's because it's more left of the y. So yeah, so you're starting with the x and then you're interleaving it with the y. That's just like the way the question is kind of having it. So that's why it's the x and then the y. Um, but yeah, because you're kind of just doing that order, but if it was flipped around, then the y would come before the x.
Is that all?
I'd like to do one more question.
Sure, which one?
I don't have anyone any particular anyone in particular. I think another like recursive question would be good.
Yeah. Number. Nope. Oh, this one. Is this recursive? Yeah. But this is the same thing, is it not?
Yeah, that's the same thing.
Okay, then actually no, then let's just
Okay.
do an output question instead.
An output.
Yeah, yeah.
Also like this.
Yeah.
Let's see. So line A, we are looking at position 2 of row 2 and column 2 from this X array, right? So this is like your first row, your second row, and your third row. So, well, I mean, you start at 0, right? So this is 0, 1, and 2, right? And then if you do your columns in this second row, you would have 0, 1, 2, and you would have 5 for this output. Because this is, let's see, 3, 1, 4, 1, 5, 9, 2, 6, 0, 1, 2, 0. So you just follow this, right? And you can get here. Any questions on that?
Okay, so I understand like with the 1D array, right? So that
Mm-hmm.
that specifies the capacity, how much is going to be in the array.
Right.
But when it's a 2D array ends up being rows and columns.
Yes. So
Okay.
this one, this first index will indicate your row. The second one will
Yeah.
be your column.
Hmm.
So here it's 2 or 2 and then columns.
Okay.
So if this was like 1 here, you'll look on this row.
Okay, so that's going to be the amount of entries in that row in the row. And then the second array, the second brackets determines how many of those rows are going to be there.
Uh, Not like how many, just like your position. So like, if I
Okay.
have this as position 2, you go to it would be this second position, right? Because it's 0 index based.
Hmm.
And then the second column would be 2 also. And then you just have it where they meet up. So if it was like
Okay.
1, 1, 0, it'd be this first or this row and then the first element, which would be 1 if it was 0,
Okay.
1 rather than 2, 2. Okay, the
Okay.
second one, please. Clear. 3, 1, 4, 1. So this is so this is one index. This is the or like the column in the row. Row column, whatever. So we would get the value from this uh these two positions, right? So we have 2 and 0, which is 2. So the value in this X position would be 2. And then for the second position for the columns, we would go for the array that's it's the same array. So yeah, so 2 again. Because this is 2, this is 0. That's 5. Mhm. So does this make sense to you?
Okay, so it's in second row, and then you're gonna pick the second entry in that row, right? So that would be 9.
Sorry, no. You're talking about this spot right here, right?
Although the one that you just wrote down, where it was x2, 2.
Uh, right, x22 here is from, so we get the value of this position of the array, and that will
Okay.
be our value for this outer array, right?
Mhm.
So we get the value at 2, 0 from this inside to use it as our value for outside. Right. So if like let's say this was not select to what I erase. I don't want to erase everything.
Okay, so solving it, so solving
So
the index inside that array, that's gonna be 4, because looking at we're counting 0, 1, 2, then that entry would be 4.
0, 1, 2. Sorry, where do you see that?
Oh,
I'm
and
talking
inside that array, so where it's x
right.
in brackets 2 and then in brackets 0. So
Yeah.
you count 0, 1, 2, and then that number is gonna be 4 since we start counting from 0.
No, because this spot right here is your row, which is here.
Hmm.
This is your row.
Oh, okay, yeah,
Yeah.
that's right.
And
Yeah.
then this is your column on the you go left to right.
Hmm.
So you do you yeah, the value would be 2 here because this is the 0 column.
Yeah, yeah.
If you wanted to get 4, it would be 0, 2, not 2, 0. Does that make
Okay.
sense? And then
Yeah.
it's the same at the as the second argument. Uh, Now for this for loop, we want to go through our rows, which is 0, 1, 2, right? We want to go up until r is less than 2, starting at 0. So we hit this row and this row, but not this row because this is not true, right? And so on the first x, we would print 2, 0, and that is this spot right here. Wait. I'm fine. It's this spot right here. 2, 0 is 2. Next iteration, when it's 1, we would have that's 1 right here. And that would be 6. Because this 0, 1, 2. And then we would just about 3. Or a 2, I mean. Two, 6, yeah. That makes sense?
Yes. Yeah. So the first set of brackets is the rows, and then the other set of brackets determines which entry in that row.
Yeah.
Okay. Yeah.
So for that, it's just going to see out 6 two times, right?
No, it'd be 2, 6.
Oh,
Because let's see. Because at 2, 0, because this first
because the index
yeah,
changes. Right.
it starts at 0, and then the next one is 1, which is 0 and 1, or 0, 1, right? So it'll print 2, 6, but in different lines up. So now we call this up function. Okay. So the up function, we pass our array, our rows and columns. Oh, this is nested. Okay. So for this first one, we will do one iteration for the column and the row. And then we'll see out 10 plus whatever index it is. Let's see. So at 1 and 1, or at 0, starts at 0, increments this. Let's see. So this first one would be 3 plus 10, which would see out 13. The next iteration for R would be 1, but 1 is less than 1. 1 is not less than 1, so that would just stop. We do the same for the first for loop, and that's also 1 is less than 1 when it increments, and so we just stop. So I think it's just 13. Yeah, 13.
Wait, so how do we get 13?
So we pass in 1 and, oh, that's a check mark. What? We pass in 1 and 1, right, for this first call. Right, 1, 1. And then our for loop will only go up to 1. When we run
Okay.
this nested for loop, our initial values are 0, right? So 0 for the
Yeah.
row and 0 for the column.
Yeah.
On this first iteration, we just get the value of x at 0, 0, which is 3. And then 3 plus 10 is 13.
Yeah.
We'd see out that. And then we go to the next iteration for the inner for loop for R. That will be now 1, but 1 is not less than 1. So we can just break out of that, and then we'll go back to the outer for loop. In the same case for this, we'll increment the C. That'll be now 1. 1 is not less than 1. So that will break out, and then we can just see out an end line.
Oh, wait, so
So
this is still a nested for loop?
yeah, this is a nested for loop
Okay.
because we have a
Hmm.
for here and a for
Yeah, because
inside
I
the
noticed I
for.
don't see, because I noticed they have put the two for loops right next to each other, and there's no, I don't see
Yeah.
curly brackets. Okay.
You'll need a curly bracket if it's more than like one line.
Oh, okay.
Right. By default, with the for loop, if it's on the same line or the next, it's kind of like within the for loop.
Hmm.
So we do that for 2 now. If we increment or we change this to 2, this first one would still print 13. Now we'd increment this for loop. Let's see. Now it's 1. 1 is less than 2. This is now 1. 1, 0 is 1. Plus 10 is 11. Then we increment this to 2 again, the row. That would now not be true. So go out to this outer for loop. increment this to 1. This will now do for loop again, starting at 0. And this is a mess. So it's 0, 1. That would be 1. 1 time, or 1 plus 10 is 11. Then you increment the for loop again for this row. So that's 1 again. 1 is less than 2. Increment this to 1, 1. 1, 1 is 5. 5 plus 10 is 15. And then we can just finish, because now it's 2. 2 is not less than. And then this would also increment to 2, and 2 is not less than 2.
So then it's just CL, E, and DL after that.
I didn't need a. There was no end out here. Yeah. So this would all be one line.
Okay.
1, 1, 15. Not clear. All right, 13, 1, 1, 1, 1. Yeah. Does that make sense?
Yes.
All right. We have like 3 minutes left. I don't know if you guys keep doing more.
Could you explain Futurgy one more time just to help me get it on my head a little bit better?
Yeah. A little louder. You hear it completely. I mean, I didn't hear the question, so I don't know what to say at this point. But we're just like doing the for loops, or like we're just doing the nested for loop on the position and just adding 10 to it.
Thanks for the review. Have a good rest of your day.
Well,
So this was recorded and we'll have that posted. And if you guys could fill out the feedback form before you head out, we'd appreciate it.
Okay.
And best of luck on the exam, everyone. I
Thank
hope I
you.
was able to
Thank
help,
you.
and I hope that you have a good day.
Are there previous uh are there previous reviews available on the YouTube channel?
Yes, there's a lot of reviews for 111. We have them all on the Learning Commons YouTube channel as well as on the Learning Commons website as well.
Thank you.
Problem.